And we're live. My name is Robert Ronan. I'm a principal product manager here at Oracle on the developer adoption team, coming to you from Austin, Texas. Also with me today is Adao Jr., senior principal product manager with Oracle, David Schott, lead partner solutions architect with Snyk, and Eric Carter, director of product marketing from Sysdig. Earlier this year, Sysdig and Snyk announced a partnership bringing together an industry-leading container runtime and developer security platform. Together, Snyk and Sysdig are helping developers secure code and containers in development, protecting the Kubernetes runtime environment, and delivering feedback and visibility from production back to developers, eliminating the noise of container vulnerabilities. Oracle is embracing this partnership by publishing a quick start that will simplify the deployment of both solutions to an OKE environment. We're also going to have a live Q&A as soon as the webinar and demos conclude. So please hold your questions, put them into the Q&A area, and we'll address those at the end. Eric, it's all yours.
All right. So happy today to be joined by Adao, who is, as Robert mentioned, with Oracle, as well as David, who's with Snyk. This partnership has been really great. And we want to tell you about it today and a little bit of how it's going to help you. My name is Eric Carter, as Robert mentioned, and I'm with the product marketing team here at Sysdig. And as we dig in today, one of the things I wanted to do is just kind of set the stage for kind of the areas and even the roles of what we want to talk about, right? As folks are starting to move more and more to containers and Kubernetes, and the cloud, there's a lot of security requirements, and pretty much very, very similar to the old world of sort of non-cloud, let's say, but they follow us into our clouds, but they also present some different dynamics, right? So we still want to fix software vulnerabilities, but now there are things that are in containers. How do we figure that out, right? How do we make sure that what we're rolling into, for instance, a cluster on Oracle Kubernetes Engine, that we've done the best job we can of addressing vulnerabilities, especially the high and critical ones? We need to be able to manage configurations and permissions, right, of the infrastructure itself, maybe the containers and so on. But again, how do you get the visibility that you need when you might not necessarily own the infrastructure to understand how I'm doing, right? You need then, of course, when you're running things, to always be watching, right, detecting and responding to threats. And I'll share more about how Sysdig can help there. And that means, anything that you can't address from a more of a development perspective, you really, there's all kinds of things that can happen, zero-day threats, just human beings and hackers and on and on and on, right? So we want to be able to detect those things and respond to those things. And then I don't want to leave out that most of us have a compliance requirement of one form or the other, whether it's SOC 2 or PCI or HIPAA, you name it, right? So visibility into what's going on from the time we're building through the time that we're rolling these things out into production becomes really critical for meeting compliance. And different roles, developers, ops, security, might have different concerns at different points in this life cycle. And ultimately, when we think about the tooling that Sysdig and Snyk are bringing to the table, we are together addressing these things and addressing them for you along with Oracle and for the things that you're running on your Oracle cloud. If you're not familiar with Sysdig, I just wanted to take a quick second here to do a short introduction. We like to start at the left-hand box because many of you have used this tool called Wireshark. Now, we are not Wireshark necessarily, but our founder was one of the co-creators of that. And if you have used that tool, it was very critical for capturing information about what was going on your networks, being able to kind of look through packets and understand behavior and things like that. Loris, our founder, when he started Sysdig, and by the way, we have an open source heritage, both Sysdig and Falco, I'll talk about in a second, are open source. Really, the idea here was how can we get a similar level of visibility, not just thinking about network, but containers, the running environment, and so on. How can we get that kind of tooling so that we know what is happening in our containers or what happened, right? And to do that without being too disruptive at all to the containers themselves. So Sysdig open source is created for that. Think about that as forensics troubleshooting. And Falco, which hopefully many of you have started to hear about, is really about a low-level ability to watch what's going on in your cloud native environments for threat detection. And so these things all come together in effect for Sysdig and for our solutions. What we want to focus in on today is ultimately this concept of runtime security. And partly, this is part of what we do, but it's also critical for watching that running environment. And it's where we have intersected with Snyk in a way that helps us share information. We often think about the, this DevOps infinity loop, right? And the key thing is to always be improving. And if you can, use signals from all along that loop, all along that life cycle to make things better. So let's talk about runtime security. For Sysdig, this is built on Falco, what I introduced in the last slide. Think about runtime security in essence as a solution that is going to enable you to detect threats in your running applications, containers, cloud services. And again, this is trickier than it might seem because containers in essence are intended to be independent, or a bit of a black box, opaque, if you will. And the question is, how do I understand what's happening on the inside? And ideally, you want to do that without having to put a bunch of code inside the container, which is, as we start to look at the makeup of containers, it's kind of contrary. You want it to be as slim as possible. So how can you do that? And that's where Falco comes in, by observing at a low level. In essence, what it's enabling us to do, this runtime security tooling, is to capture activity that's going on, to see it like a security camera, which is why I put that on the left-hand side. Imagine being able to kind of watch everything that's going on, and almost like a security camera with X-ray vision, because we're able to help you see the activity, but also understand, hey, what's taking place inside that container without having code inside that container that is Sysdig, right? So what's going on hosted containers with, maybe it's our configurations, permissions, network connections, file IO, et cetera. The idea at the end of the day is you want to identify what's going on that you don't want happening, to block that if you can, anything that sounds or feels like malicious behavior. So if you're in the business of standing up apps in the cloud with containers, I think this is something that if you aren't doing, you should look at a runtime security solution for yourselves. Right. Let me just say for a quick second, a moment ago, I said, hey, we're doing this at a low level. Let me give you that insight into the instrumentation. So getting visibility into containers, here's our example. You've got a Kubernetes node running on OKE, some containers out there. The way that we are helping get this visibility is through system calls. Now think about system calls is everything that's running out there on these hosts, on these Linux instances, are making system calls. From that, and instrumenting, you can either use the native facility called eBPF with Linux, or we also have a kernel module at Sysdig. You're able to see all of the activity that's happening. Now, some of that activity is perfectly normal, nothing to see here, right? But because we can observe that, you can then apply filters to say, okay, but be looking for this. And you'll see this in the demo. Be looking for these things. And when those things happen, make sure that we get insights into that happening, where it's happening, the node that's happening, the insights around context with the Kubernetes and the containers and so on. And then once we understand that, we can also take actions. Again, you'll see that in the demo. Think about like stopping a container that maybe someone is running crypto mining or something like that, right? Stop the immediate threat and move on, right? So it's the same layer where we're seeing everything, that as we start talking about the integration with Snyk, that we're able to see these containers as they start. We're able to understand what of the packages that are in that container are actually being invoked. And this will lend itself well to sending that information back into the build pipeline, which we'll talk about in a second, to help understand what should I really fix here? What's the most critical things? And being able to have insights into the containers and what's actually running is key. So a summary for me in terms of the totality of what Sysdig is bringing to the table, because we're here talking about security for containers and so on. The same level of visibility that we're providing into containers, we can give you insights into how are you doing against your environment configuration according to best practice, things like CIS benchmarks and so on. Because this is a way for you to make sure, just like you want to secure your containers during build, that you're securing your environment. Runtime security, which I just touched on, you can build and set policies, and you can even, you can monitor those events. Maybe you've got a security operations center that needs to see, hey, these are the things happening, and these are the things we need to take action on. And I mentioned that having information about containers, especially when containers might be stopped and you may not have the information. We want to be able to help you capture that. So you have audits and ways to investigate the activity and to run forensics exercises and so on. So there's a number of things around cloud containers and Kubernetes that Sysdig can help you with if you're in need of finding a solution that can help you with any of these things. I think that brings me to the end here. So let me pass it off to David so that he can start talking about the Snyk angle to this story. David?
All right. Thanks so much, Eric. I got to say, I love the deep runtime insights that are coming out of Sysdig Secure. Thanks for sharing that. Maybe we should partner up on that. I'm just kidding. We already have. Anyways, hi, everyone. I'm David Schott from Snyk, and I'm going to speak to you about Snyk Container and provide additional details on the Snyk and Sysdig partnership. So another way of looking at the container security spectrum is to use an airplane analogy. In order to have a safe flight, you need to build a safe airplane and you need to have in-flight safety systems. You can't remove either of those. A shoddy plane with a great in-flight safety system will crash, and a plane with the highest level of safeguards but no in-flight safety systems is still going to crash. It's not a question of either or. You need both. Snyk helps build the safe airplane. When you run a scan on your containers, we show you the vulnerabilities, but our output and goal is to help the developers fix those vulnerabilities. We don't just show raw CVE lists. We tell a developer which vulnerabilities are in the container's base image and whether there's a newer and better base image that can be used. And we show them where vulnerabilities are introduced in their own user layers of the container as well. Now, most of the existing container security tools are the in-flight safety systems. Yes, they also scan for vulnerabilities, but the output of that scan is used to determine if A, the container is even allowed to run, and B, when it does run, it helps to set security policies like network rules that might prevent attackers from being able to reach the vulnerability, or behavioral rules that alert you if someone uses a vulnerability to launch an attack. But they don't provide the type of detail that is needed by developers to fix the root cause. And that's why we built Snyk Container. Snyk Container is the only solution that helps you integrate security into your developers' everyday thinking and build process. Snyk doesn't just produce a list of vulnerabilities in containers. Snyk Container has been used to fix millions of vulnerabilities in containers to date. Now, there are three key ways that Snyk Container helps your application teams to build and use secure containers following the three requirements for developer-first security. The first requirement is to empower developers. This means it's free to get started with 100 container scans per month. It also means that Snyk embeds container security expertise into the tools that developers use every day, like their IDE, their source code repository, their CI/CD process, and much more. Another requirement is to automate fixes. This means fix pull requests to take developers directly into action instead of ticketing and triaging. And fixes can be as simple as a fix PR button or even automatic pull requests. It also means base image upgrade recommendations to guide developers to better, slimmer images with fewer vulnerabilities and to keep those base images up to date. The last requirement is security intelligence. This means prioritizing issues quickly with severity, exploit maturity, contextual data about the Kubernetes configuration, and more. It also means priority scoring, which automates and combines the analysis of all of these vectors to provide a single score. So to recap, remember that containers are more than a Docker file. They also contain your application, and they're deployed using infrastructure as code. Now, Snyk Container helps you find and fix vulnerabilities in each of these areas, while also helping you choose the best base image and keep it up to date. On top of that, Snyk Container can sit inside your Kubernetes cluster, helping you continuously monitor and protect applications after they've been deployed. So going back to the plane analogy, Snyk Container helps you build a safe airplane with some in-flight controls. But we identified a need for a bigger and better cockpit with more controls. And that's one of many reasons why we partnered with Sysdig. When most people talk to us at Snyk about container security, they're primarily considering their production environment and how they're going to protect applications in motion. And this makes sense because production is where bad things usually happen, since that's where the applications are actually running. But containers are not solely a runtime concern. In fact, containers and Kubernetes are where dev and ops meet from a technical standpoint. And as any developer would tell you, if you put garbage into the system, you can only expect to get garbage out. When Snyk Container and Sysdig Secure are both deployed into a Kubernetes cluster, you can connect them together. When Sysdig detects that vulnerable code is executed, it shares this data with Snyk, and the Snyk UI is decorated with additional context about the vulnerability. Now, remediating vulnerabilities can be difficult and time-consuming, but with Sysdig, developers and security teams can better understand and prioritize the risks they face in their production environment. Through our partnership, we help developers build secure containers in the areas they're working, like their IDE, pull requests, and CI/CD pipelines. And we give security and operations teams the insights they need to protect their runtime against an ever-increasing number of threats. And we help everyone using our products to identify the threats that matter most, which eliminates noise and puts the most important issues at the top of the list. So with that, I'm going to hand it over to Adao, who's going to tell you how all this works on Oracle Kubernetes Engine, or OKE. Adao?
So, right now, we'll be showing you how you run both the solutions on OCI using the OKE. OKE is our managed Kubernetes, and that use the upstream Kubernetes, and that you can have a full Kubernetes engine that you can use, and with different shapes, like you can have nodes on ARM, on Intel, you can use GPUs, and you can like do quick installations with your other solutions like Snyk and Sysdig. When you install the OKE on OCI, you're deploying a full Kubernetes that you can have different nodes and different agents that you can work together, and they would normally you see they are using the whole infrastructure. Like you can, when you generate a load balance on Kubernetes, you generate a load balance infrastructure. You generate like the storage when you're using a volume there, and everything can be managed and accessible using like regular Kubernetes commands, like using the kubectl or Helm charts, etc. That's a view that you can see all your clusters. For that demo, you can use your existing cluster, or you can create a new one. You have two repositories that's a quick start for Sysdig and Snyk, where you can do the install and do the integration using one click. You have a magic button here that will be deploying for you, Jace. You can decide to either install separated the Sysdig and Snyk and have two different packages, or you can do a one install and install both and do the integration directly on Jace. When you talk about the magic button, that's basically a Terraform script that runs directly on the OCI. You don't need to run your machine. You can also use a regular local Terraform, but or you can use the resource manager that will be deploying everything for you. Okay, so I'll be starting now. That's the link. You probably send that on the chat as well. So let me put in the link as well. Here you have the repository for the quick start for Sysdig and for Snyk. In that demo right now, I'll be using Sysdig to start. So when you click, they will open you the OCI console, and you get from GitHub the stack. That's the Terraform scripts in a zip file. As soon as you agree with terms, that shows you that stack. You click next. There are all the fields that you need to include to do that deployment. So I have opened my Sysdig secure, and I can copy all the variables that I need. So the first one is the access key. Let me copy this one here. I have also the agent collector URL. I need to use that because depending of the region that you're using, that's going to be different. And then endpoint analyzer. On that stack, I can choose as option to enable the integration from Snyk and Sysdig. Let me include it here. For Snyk, I need just the Snyk integration ID that I have also open here. Let me copy that ID right now. You have like other options, like if you wanted to deploy a sample app, that's the goofs from Snyk. That's an example of a vulnerable application that you can test and see that on the console. And if you have a private registry and you need to enter the credentials, you can also include it right here. I'm not using that just right now. That stacks allow you to select you can create a new OKE cluster if you don't have yet. You can also create from the OSI console one, or you can just go and select one existing one. Let me use this one, but I prepare for this. Yeah. So next, you can review all the configuration that we included. Make sure that you have the run apply checked. That means that they will load the Terraform scripts and they will be applying the Terraform. And that's it. Like there were workers, they have a Terraform workers on the OCI, from the resource manager, that will be deploying everything for you. As soon as they finish, you'll be able to see inside that cluster. And if you want to check inside, just go to access cluster and you see all the pods and everything running there. You can use the Cloud Shell if you want, or you can use a local machine. Here you have all the instructions. Yeah, the Cloud Shell is just like a terminal that runs and have all the security configurations to access that tenancy and that cluster. When you use that command, you include that on the kubectl for you. Okay. I think that's it. Like you have everything installed. I'm now be passing back to Eric, and you'll be showing like after you have that deployment and have installed, how that you will be looking on the console from both.
All right, let's get into it. What we're looking at here is the Sysdig secure user interface, and this is the main window into all of the security capabilities available with Sysdig. And this particular screen is a summary of activity across all of our managed clusters, and all the issues of concern will be bubbled up here. Now, I can click on this particular cluster running on Oracle Cloud and see what's happening, right? And the key starting point for this is to choose the threat detection rules you want to enable in your environment, right? And let's go ahead and take a look at that now. So I'm going to go to our rules library, and these rules are based on open source Falco, and we can do things like look at our workloads and Kubernetes audit, right? And you'll see a number of options in here related to suspicious activity, things that the community and our customers have told us are important: creating disallowed namespace, let's scroll down, launching disallowed container, suspicious network tool, and so on, right? And we've tagged these all for things like compliance policies and so on. So when it triggers that you're at risk of violating that particular compliance standard, for instance. And using the underlying Falco engine, you can also customize, and this is kind of what that looks like, the rules. You can customize and build your own to fit your specific use case and scenarios, essentially saying, look for this, and when that happens, tell me this particular information, right? And for containers, we're monitoring activity at a low level, as I mentioned, through system calls. And it's this same vantage point, essentially our security camera that we're using to understand what packages are running inside of a container and giving that information back to Snyk. What we can do is we can take these rules and build them into runtime policies. And you'll see our library here that come out of the box, as well as ones that we built. And let's pick our suspicious container activity. And you'll see here that we're using 4 rules inside of this: terminal shell and container, launch disallowed, and so on. And these can be tuned in a way to fit, in your environment. Right now, I've got it scoped to my entire infrastructure. But one of the things that we can do is to actually say, well, instead, I want this tagged into or monitoring a particular, Kubernetes cluster, for instance, right? And maybe I want a difference in how I monitor prod versus dev or whatnot. So I can pick, for instance, my OCI cluster here, right? And so now I can fine tune that to cluster or deployment of pod container and kind of make it exactly how I need it, right? And then there are some actions you can take. Of course, you can do things like notifications, send that off to the notification channel of your choice. But also, when something suspicious is happening, you can choose to have the policy automatically do something like kill or stop that container. So what I mean by that is, let's end the immediate threat, right? And let's make sure that that's not going to impact us, long term. Kubernetes will spin up another one, and we're on our way, and we can go look at and see what happened. Speaking of which, in addition, here you can set a capture recording. Now, this is unique to Sysdig. This is going to record the before, during, and after the event that you can use for detailed analysis and forensics. And this information is really key, especially after a container is no longer running. This will help you to be successful in your container security investigations. So let's say we've dialed in our policies in our environment. What's the next step? We can look at our overview page, but we can also look and see, tell me what's triggered in the last hour in my environment. Got a lot of things, right? I can click on one of these particular issues. And what I do is I get some detail of what happened, right? What's the rule that was triggered, and get information into things like what Kubernetes cluster did this happen in, deployment pod, node, and I can get container information all the way down to process information, right? And this is very helpful because in a cloud native environment, things can be spun up in a lot of different places. This points us in the right direction. But let's say I want to dive deeper. So we can do that with what we call at Sysdig an activity audit. And we get dropped into the time of the event where you can investigate important aspects such as the network and file activity, Kubernetes activity, command line activity, right? And here we see a readout of the things happening in and around the event we were looking at, and we can get further information by clicking on this. So activity audits across the environment are useful for recording what's going on, useful for things like audits and so on. Now, earlier I mentioned captures. This will be the last thing we'll look at before I hand it off. If we have a policy set up to take that capture file, so let's go back and look at our response options. And here we can view a capture with inspect. So this is that sort of a dump of system calls that we've organized for you into these tiles. And this gives you some idea of what was taking place in the environment across different aspects, right? And in this case, somebody got in and was doing some things around commands, but probably also accessing files. The cool thing here is I can double click on this and see things like what exactly was in this particular, HTML file. So we get a readout of sort of the reads and writes that were happening in the environment. So think about this as a way for you to see exactly and reconstruct exactly what was happening in an event, around an event in its entirety, right? So let me go out of full screen here and bot back over. So in this segment, we looked at runtime security rules and policies, as well as how to observe and investigate events. And the visibility we gain through this runtime security solution, as I mentioned earlier, provides insights back to the build pipeline with Snyk, right? Indicates exactly what packages are being used by giving container and production and exchanging this information, as you're going to see in the next demo. You will be able to more effectively filter and prioritize exactly what to fix back in your build pipeline. So with that, let me go ahead and hand it back over to David.
Hey everyone, how you doing? This is David again, bringing you a brief demo of Snyk Container. So if you remember from the presentation, Snyk Container is a SaaS-based solution that helps developers find and fix vulnerabilities in their container images. And the way that it does that is by integrating with the tools that developers are using, like their IDE, their source code repository, their CI/CD pipelines, all the way to their container registry and runtime environments such as Kubernetes. Now I'm going to show you all of these integrations during the demo that I've prepared for you today. But before I get too deep into the Snyk user interfaces, what I want to do is put on my developer hat and show how Snyk is integrated into the software delivery lifecycle from the left, in other words, the developer's workstation, all the way to the right, which is our production Kubernetes environment. So let's say we're a developer, we're working in a directory with some source code in it, and we just built a container image. Well, we can get started with Snyk Container using the Snyk command line interface, or CLI. So once we have it downloaded and installed, it's just a matter of running the Snyk container test command along with our image name and a pointer to our Docker file. And then Snyk is going to open up this container and show us where the vulnerabilities are. Now, while that's running, I also want to point out that Snyk is available for all of the most popular IDEs out there. So in my case, I'm using IntelliJ with the Snyk extension. And what Snyk is doing is really all four of Snyk's products are scanning the source code for vulnerabilities in several different areas, from the open source dependencies that I'm using, to the first party code that I'm writing, to the infrastructure as code that I'm writing to deploy my software, as well as the container image that I'm using to package my application. And in each of these areas, we can click through to find more information about the vulnerabilities. And again, this is right in the area that a developer is working before they even commit their code. So as we work to the right, let's then show how we integrated Snyk into our tools. So I'll go over to the integrations tab, and we can see some of the things I've already mentioned, like source control systems, container registries, and so on. And you can see I've already integrated a number of these tools. It's really simple, just click through and get Snyk plugged in. And once we've done that, it's very simple to click Add Project and onboard our applications into Snyk. So starting with our source code repository, we can see Snyk is integrated with a few very vulnerable applications here. And clicking through, again, we see all four of Snyk's products scanning for vulnerabilities in several different areas of our source code. So for Snyk Container, we're looking for the whale icon here. That means we've got a few Docker files in this project, and clicking through, what we see is first some metadata about this container image, like who imported this project, who owns it, where it came from, as well as user-defined tags, which are important for filtering and reporting. We can group our containers into the ones that we're interested in. And then as we scroll down, we can see the vulnerabilities that Snyk found in the container, as well as all the dependencies and tools inside that container. So this is really how it's working, is Snyk Container is opening it up, looking for the package manager, application manifests, and then taking these tools and libraries and running those against the Snyk vulnerability database to surface where the vulnerabilities are. Now, for each vulnerability, we provide information about how that vulnerability was introduced, whether a fix is available, and if so, which version it was fixed in. We also show information about exploits, like if an exploit exists, in this case there isn't, but also if it does, how mature is that exploit. And then we take this information that we know about the vulnerability and we factor that into a custom priority score. Now I'm going to come back to that in a little while, but it uses more information that we know about this vulnerability beyond just the public CVSS score. And this, of course, helps security teams to prioritize the issues that matter most. Now, scrolling up, one of the most unique things about Snyk Container is its ability to recommend a base image upgrade. Now, this is very important because the majority of vulnerabilities come from our base image. And as we can see here, we're using this version of Tomcat, which has hundreds of vulnerabilities. And if we simply upgrade to a new minor version, we can reduce our vulnerability count by an order of magnitude. Or if we want to be a little bolder and try something like a major version upgrade or a different Docker tag, we can reduce our vulnerability counts even further. And remember that since we're integrated with a source control system, we're able to open a pull request. So with just a click of a button, we can open up a pull request and implement this base image upgrade recommendation by simply merging that into our code. So going back to the projects view, we've seen how Snyk integrates with our code repository. Now let's pretend we commit code to that repository and then we run it through a CI/CD pipeline. So there are many CI/CD tools out there. In my case, I'm using Jenkins, where we have a Snyk plugin available to help you quickly and easily get started using Snyk. And if you're an advanced user like me, you'll want to use the Snyk command line interface, similar to what I did in my terminal, but we can use it again in our CI/CD pipelines. So this is a very simple example. I'm just running some Docker commands here to pull vulnerable containers and build them. But the important takeaway here is we're using Snyk Container Monitor to not only scan for vulnerabilities, but also push that information up to the Snyk user interface, like we're doing here. And since Snyk is part of our CI/CD pipeline, we can implement things like thresholds. So for example, whenever high or critical vulnerabilities are found, we can block the build and prevent that vulnerable code from being deployed. Then we push our container to a registry, so showing that here we have Snyk Container finding the same image in our registry and really showing us the same information as our source control repo and CI/CD integration. And then we pull that container from our registry and deploy it to a Kubernetes environment. So here we see a couple of Kubernetes, Oracle Kubernetes Engine clusters running with various vulnerable applications. And to show a bit more about how this works, we can run this command, which shows that in this OKE environment, we have the Sysdig agent as well as the Snyk monitor deployed. And it's very easy to deploy these, connect them together to show how our integration works. And I'll show you here. So if we click through, we find that in this deployment, we have actually a couple of containers that are running this deployment grouped together by the Docker image tag. And inside this container, it's important to remember that we not only have our base image and any tools that we installed, but also our application that we installed into that container. So Snyk is separating our application and the base image like so here in the UI. So clicking through on the base image, we see really the same information that we saw before in our code repository integration, but let's pretend for a second that we've implemented Snyk's base image upgrade recommendation. So we don't have 1,000 vulnerabilities. We have, let's say, 43 vulnerabilities that we're looking at in this list. Well, how do we prioritize the remaining 43? Well, with Sysdig installed in this cluster, it is sharing execution at runtime data with Snyk. So what we can do is filter down that 43 to only the vulnerabilities that have been loaded and executed at runtime. Now, this is very important because what it means is that the code around that vulnerability has been run in a runtime environment, and that information is also factored into our priority score here. Not only the runtime information, but also some contextual information about how this container is running in our Kubernetes cluster. So this is very important because it helps security teams to understand which vulnerabilities are the most critical, which ones are affecting users, and which ones are putting the organization at the most risk. So with this execution data, the security teams are probably going to want to have developers fix executed vulnerabilities before looking at other things. So that's all for my demo of Snyk Container. If this was interesting for you, please feel free to go to our website, snyk.io. You'll find Snyk Container under our products, and it's very easy to get started and try many of the things that I've shown you today. So thanks so much. I appreciate it. Thanks for listening, and have a wonderful day.
Thanks, David. So with that, again, awesome presentation. Excellent content. I've got a couple URLs here if you want to get started with Snyk or Sysdig, or if you want to get started with OCI or even OKE, which is part of OCI. We do have time for some questions, so I'd like to start that. Question-wise, the first question is, what do I need from Snyk to get started with this integration?
Good question. Thanks, Robert. Well, as you saw in the demo, you really don't need much. You can, if you're a developer, you can download the Snyk command line and use that right away. Or if you're working in a development environment like Eclipse, IntelliJ, VS Code, you can download the Snyk extension right there to your IDE. But all of those paths, I think, are eventually going to lead you to our website, snyk.io. So really nothing is needed. Just go to our website, click on Snyk Container, sign up for free. It's super easy to log in with SSO on Google, GitHub. And once you've done that, you can do all of the things that I've shown you today.
Thanks. This one is for Sysdig. So what's the difference between Falco and Sysdig Secure?
Let's see. When we think about Falco is very purpose-built for threat detection in and around containers, Kubernetes, and actually now there's a cloud component to that as well. Falco, you saw, I think, in the demo where I opened the box and there's like the syntax, and it is in essence, you're working kind of more from text and what looks like a YAML file. You're saying, let's name this rule. Let's dictate what conditions we want to look for, and then when it happens, spit out some information. And then from there, users can decide, what to do next. There's something called Falco Sidekick. You can get alerts and things like that, or you can take actions that you build. When that's built into Sysdig Secure, first of all, Sysdig Secure does more than just runtime security, as I think I showed on one slide, where there's various security capabilities that exist to kind of help you, understand how your environment's configured and so on, and even the audit captures and things like that, right? In the Sysdig Secure, we're now operating more as a SaaS platform at scale, so that you can apply this against large and growing Kubernetes estates and things like that. We also have the built-in, as I showed, the ability to take actions like kill a container, and so on. And so what we've done is use the Falco detections, but built it into more of a UI-based SaaS solution that will help you to do even more, making sure that you can respond to the things that Falco detects. So Falco is open source. Sysdig Secure is not. That's more of our commercial SaaS offering. So I'll leave it at that, Robert. Yeah.
Great. Next question. Does the integration show any package ever executed, or only packages running within a specific time frame?
Yeah, we've gotten this question before. That and David can chime in too. No, I mean, because as you think about an environment with containers is changing and shifting a lot, right, all the time. Not the least of which is that we're fixing some of these things. So there is a throughout the day, and I think it's down to a 20-minute segment where the information is being passed back. So the key thing is what's running and what's running now, right? And so that information is there. It's kept captured in Snyk, where you can hit that executed button. But what was running yesterday, may be different today, right? And so having that fresh insight, and it may be 100% the same, but it may not be. So that insight is important so that you know exactly what to address. Anything to add there, David, or did I do okay?
No, that makes sense. I mean, from the Sysdig perspective, you're getting, these deep runtime insights and seeing that sort of live information. And, again, Sysdig is sending that data over to Snyk, where the Snyk UI is decorated with that execution data. But from the Snyk perspective, we're going to tag and permanently tag vulnerabilities as being executed. And one of the important reasons for doing that is because certain parts of our code might only light up for a short time period. And if that part of code is vulnerable, that's worth knowing that not only is it vulnerable, but it's also been executed at some period of time. Think of it like, a process that only runs for 20 minutes every day. If you have that in your software, that's certainly a possibility. So from the Snyk point of view, we're going to leave that executed tag on the vulnerability 24/7 permanently.
Also, I wanted to make a note here. Adao has put a few links into the chat for the Sysdig and Snyk quick starts. Make sure you check those out and grab those before you leave today. We got time for a few more questions. Next one is, what else is planned for the integration?
I'll take that. So bear in mind that this integration is relatively new. We launched this, what was it, Eric? Just a few months back.
Yep.
I think the teams have done excellent work so far. You saw in the demo that the Snyk UI is right there. It's very easy. Like I said, once you have both of these installed into Kubernetes, it's just a flag that you turn on that says Sysdig integration enabled is true, and everything just kind of happens from there. One of the things we did post-launch was to take the execution data and factor that into the Snyk's custom priority score. That's very important for Snyk because we want to help security teams to understand all the different factors that represent a vulnerability, not just the public score, because that could be misleading. But there's definitely more things that we have in our backlog, on our roadmap, things we want to do together. I think right now the Sysdig component is sharing data with Snyk, and next we want to see how Snyk can also share data with Sysdig. But stay tuned. You've got a quick and truly very easy way to deploy exactly what you saw today. So you can stand that up, start experimenting with it, and call us at either Snyk or Sysdig to get more info on your question, and stay tuned for more.
Yeah, it's a good point. I think in addition to the quick start, like the quick start is meaningless if you don't have the solutions, but each one of these I think you can get as a free trial and give it a go. And then, we are always wanting to hear feedback on, hey, it would be great if you could do this as well, right? So anything that comes our way, we'll listen to and try and factor in. But that's a quick plug for getting on any of the links here and getting a free trial. As I like to say, you can go to just about any page on sysdig.com and click a button.
True.
Two more questions, and I think we've got time for both. Does Snyk recommend base image upgrades for custom-based images?
That's a really good question. I think the majority of the containers that we build are based on, official, not always secure, but official images that we find on various registries on the internet. But a lot of companies out there can't rely on those, or have certain requirements and reasons to build their own custom image with their own tools. They might do security hardening, et cetera. And in those cases, this is actually a new feature from Snyk. I think it was this year that we launched support for custom base images. So the answer to the question is yes, we do support your custom base images. It's really just a matter of going into your settings in Snyk container and essentially flagging an image as a custom base image. And then Snyk's going to take care of the rest and suggest base image upgrades, just like it would for any other container image.
Last question. Does this, and when I say this, Sysdig and Snyk, does it work on any Kubernetes instance and running in a public cloud, AWS, Google, Azure, what have you.
Yeah, I mean, I think just as we've demonstrated today, the ability to run in the cloud, on OKE, it's a similar fashion. You can do it elsewhere. You can even, run these things in your on-prem cluster and be doing the monitoring and all of those things as well. Of course, Sysdig and Snyk in these instances are the SaaS backends, but yeah, it's pretty flexible as it relates to that. So no worries wherever you're deploying your Kubernetes. And of course, Robert, we want that to be on Oracle. but just know that you're not kind of locked into one kind of Kubernetes.
Fantastic. That's all the questions for today. We've got about 7 minutes left. I wanted just to take an opportunity and thank everybody for attending, the attendees, the participants, the speakers. Everybody did fantastic. Thank you so much. Any closing remarks from the Snyk or Sysdig teams?
Thank you so much for having us. It's been a pleasure. This partnership has been amazing, remarkable in so many ways. Huge kudos to Adao for his hard work on the quick start solutions, which me, Eric, and various others have already used several times to get these things deployed. Just great teamwork all around. And thank you all so much for coming here today.
Yeah, I just echo the same. Thanks, everyone, and thanks for participating.
Thanks again.